Assalamu alaikum, I am Awais Akbar, and what I have been tasked with is to simulate and record a video of all the MES labs that we have performed in this semester. So let's start by having a look what our tasks were. Okay, so in lab 1 we have 3 tasks: Arduino ID, LED blink code, and blink LED in Proteus with Atmel Studio C++ and assembly code. So let's start with Arduino ID code. So our first task is quite simple because it was introductory one, so there is nothing to explain in it. We have declared the LED as output, and then we are turning on the LED and giving a delay of 1 second, then turning it off, and then giving a delay of 1 second, and this thing is in a loop. So next we have C++ code. In the same way, like we did in Arduino ID, we have declared specific pin number 5 of port B as output. Then in while loop we have turned the LED on, then given a delay of 1 second, then turned the LED off and given a delay of 1 second, and this continues because it is in while loop. Moving to assembly code, the same thing here. We have declared port B as output. We have set the pin number 5 of port B, that is turned on the LED, then given a delay, then we have turned the LED off by clearing the 5th bit, and then a delay. So this thing is in a loop once again. So let's see by simulating it in Proteus. First, C++ code. So our LED is blinking at 1 second delay, and the next we have assembly code, and here our LED is blinking fast because we have a lesser delay here. So that was all from lab number 1. Moving towards lab 2, our first task is to store 30 in R16 in binary and display it on any port, then add 25 to it and display it on any port, and show the simulation in Atmel Studio. So let's open Atmel Studio. Let's run it. Okay, in the first line we are storing 30 in register 16. In the next line we are storing 25 in register 17. In the third line we are storing the contents of register 16 in port B. Let's have a look at it in the simulation. So the contents of R16, that is 0x1e, are stored in port B successfully, and in this step we are adding R16 and R17 contents and storing it in R16, and then in the next step we are displaying the contents of R16, that is the sum of these two numbers, in port C. So let's have a look at it in port C simulation. Here the sum of 30 and 25 is stored in port C, and then clearing the contents of register 16. The second task of lab 2 is take an input from one port and display it on other. Simulate on Atmel Studio as well as in Proteus. Opening Atmel Studio. In the first two lines we have declared port B as input port, and in the second two lines we have declared port C as output port. Then we are putting the contents of pin C in R16, then we are storing 25 in register 17, then adding the contents of R17 and R16 and storing the sum in R16 and displaying the contents of R16 on port B. Let's simulate it. So now we can see that on port B we have value 0x019, that is the sum of R16 and R17 stored in R16. Moving towards Proteus simulation. Here we can see that all of the switches are turned on, So all of our LEDs are on. Let's turn two of them off. Maybe there is some simulation error. Let's run it again. Yes. So we are taking input from port B and displaying the results on port C. Task 3 of lab 2 is quite simple. We have to display the charging sequence of LEDs on any port and simulate on Atmos Studio as well as at Proteus. It's quite simple. The code is quite simple. We have taken the first bit of port B and let's run it sideways. Okay, so we have taken the first bit of port B and set it, that is turned on the LED if it is attached to it. Then after a delay we had cleared it. Then coming to the second bit of port B, we have set it here, it's on, for example if LED is attached here, and then after a delay we'll clear it. It's clear now, and then moving on like this. Putting this code on Proteus, we'll see the charging sequence like this. Task 4 is take two values from different ports, compare them. If they both are same, then show this thing on third port, and if they are not same, then show this. Simulate on Atmos Studio as well as on Proteus. Simulating on Atmos Studio. In the first 4 lines we are declaring port B and port C as input ports, and in the next 2 lines we are declaring port D as output port. Then these two are the numbers which we have to show in case number 1 and case number 2. Reading the value from pin C and storing it in R17, reading the value from pin B and storing in R18, subtracting both of them. If they both are equal, then the subtraction will result in 0. BRNE branch if not equal means if the result is non-zero, then it will move to this line R22 in which this number is stored, which was given in our question, and if the result is 0, then it will move to R16 in which this number is stored. So let's run it on Proteus. Now we have different numbers here, one which is on and the other is off. So it shows the sequence 0011 0011. That's it. Task 5 of lab 2 is kind of theoretical thing. Implement following commands and write your comments about its functions: STS, jump, move, out, subtraction, increment, decrement, and complement. So the first function is STS. STS is used to store data contents on a given address. Jump, move from one point to other. For example, here we have written jump here, so it will move from here to here. There is nothing in between them, so this is just a empty while loop type of thing. Then we have move command. Move command is used here and it moves the contents of one register into other. Out command is used to take value from registers and give it to a specific port. Then we have a subtraction command. The subtraction command is used to subtract the two numbers and it stores the value in the first register used in the syntax. Then we have increment command. Increment command is used to increment the value. Whatever is in R18, it increments it. And decrement command decrements, for example in R18 the number is 16, so it will decrement it to 15. And then we have a complement command. Complement command is like we can understand it in binary. For example, the number is 0010, so it will complement and make it 1101. That's it. Moving towards lab 3, our first task is write a program for 328P or 2560 and interface 2 7 segments and make a counter from 0 to 99, and we have to do it on Proteus. First of all, let's move towards code. The code is pretty simple. We're declaring port D as output, and then from start to beginning with an increment of 1 each time, we are displaying the values with delay of 150 milliseconds. Let's run it. It's displaying the values. After 9 it's going like A, B, C, D, E, then next number here it will move till 9, and then A, B, C, D, E, F, and 3 here. Task 2 is write a code to interface the hex keypad with Atmega 328P and glow any LED with the input from any key button. We have to do it on Proteus. The source code is pretty simple. We have made all of these pins as 1, and when any of the pin is set, for example 4, 5, 6 or 7, any of them is set, we have connected 4, 5, 6 and 7 to the hex keypad. So if any of them is set, that is like, it is just like a switch. You can see the hex keypad is just like a switch. From this is inside view of it. So if any of them is set, then we have to display this thing, that is turn on the LED that is connected on this bit, else all of these are 0, and LED is connected here, so it is 0, means the LED is off. Let's run it, and for example we press any of the button, so LED is on now. That's it, simple. The first task for lab 4 is to connect a keypad and 7-segment display to a microcontroller and see what number is pressed on the keypad and display that specific number on 7-segment display. Checking the code, we have declared port C as output for 7-segment display, and port B, half of it is declared as input and half of it is declared as output. Why we have done this, we'll look at it later in the code. Half of the pin B is connected to the rows and half of the pin B is connected to the columns. Now what we actually are doing here is that, for example, how we will judge that 7 number is pressed. So we will say that row 0 and column 0 is pressed, and this will result as 7. As we had discussed in lab number 3, the internal structure of hex keypad, they are actually switches. So we have declared rows as outputs, that we are telling which row is it at the moment, and when 7 is pressed it will check which column and then it will display that specific number on the 7-segment display. Let's see this thing in our code, how we have done this. So first of all, this point is just a check statement. Our main code is starting from here. Here what we have done, that we have declared row 1 is equal to 0. That if row 1 is equal to 0, then it will search for the columns, that what column is it. In the same way we have declared in the next statements, we have declared row 1 is equal to 1 and then row 2 and then row 3, and we are searching the column. What's actually in the search function, it is search. How is it searching? Let's have a look at it too. For example, it is 0x07, so it is actually a binary number which represents a combination of zeros and ones. So it means that wherever that number is pressed, that key is pressed, that specific bit would be 1. So this 0x07 represent a specific on-off location. So we have actually already declared the rows, and here we have searched for the column. So now we can display this that number. How are we going to display that? We have declared two-dimensional array for rows and columns. In that array, we have now all the combination of numbers that make up something on 7 segment. Like we are not actually giving the exact value display 7 on it, so this combination actually means 7 on that display. Now let's run the code on Proteus and see it's working. We are pressing 4 and we can see 4 here, 5 here, 6 here. It's working fine. In second task, we have to connect LCD to microcontroller and display something on it. It's quite easy and simple. We have used lcd.h header file given by our teacher. First of all, we have initialized the LCD and then we have displayed my name on it. Let's quickly check what these functions are: initializing and LCD data string. Going to header file. Initializing is a series of commands. For example, the first command is initializing of 16:2 LCD in 8-bit mode. Then it's clearing, then cursor on, and goes to the first line in 0th position. There is a whole list of all these codes that represent a specific command. And next, LCD data string we use. LCD data string uses LCD data function in which it makes enable as high and then we write the data on it. So this is here we have performed this on our hardware and it was displayed successfully. It's quite easy thing. We are at our lab 5 in which we have to display the value of TCNT and TOV on LCD. First of all, we have included all the header files that we need to use in our code, then the integers and characters that we need. First of all, we have cleared the TCNT 0, then we have set the timer counter register to normal mode and the second timer counter register to 1024 prescaler. Now what we are doing in this while loop is that each time the timer counter register exceeds the value 0xFF, timer overflow, that is TOV, is increased by 1. Then we are displaying these values. At first line we are displaying the TOV value and at the second line we are displaying the TCNT value. Let's run this code and here we can see our TOV and TCNT values respectively. This is the second task of lab 5 in which we have to display counter timer on our LCD. First of all, we have included all the libraries that we need to use in our code. Then we have cleared the TCNT 0 and set the timer counter register to normal mode. We have used the timer counter register B to set 1024 prescaler. We have used a mask here that if the time limit exceeds, then it had to stop the timer. Otherwise, until this limit is reached, the timer overflow will keep on incrementing. Now we need to display it. We have set 2-digit display for second, minute and hour each. In the first line we are displaying the hour, minute and second characters, and in the second line we are displaying the values of them. The hour keeps on increasing until the specific 24 limit is reached. For minutes this limit is 60 and for second also it remains 60. Now let's run the code. Here we can see that our timer counter has started working and it is displaying in exact format hour, minutes and seconds. This is lab 6 serial communication UART part. Let's have a look at this code. First of all, we have declared all the header files, then we have initialized our LCD and declared port D pin 0 as input and port B as output. Then we have set the baud rate. The baud rate is a big number, so we have to store it in two registers. The UART baud rate register 0H means the higher one and the lower one. Next, in the register UART control and status register B, we are enabling the reception and transmission. And in the UART control and status register C, we are pulling up USBS 0 pin and UCS 00 pins. Here we are waiting for data. This is just a condition so that while the data is being received or buffered, nothing else happens and only that process takes place. Then we have the data in UDR0, so we are putting it in receive data character and then we are displaying it on LCD in character form because LCD displays in characters. The other part, which has the hex keypad, this is the database which we have already discussed in our hex keypad part, but in that scenario there was a 7 segment attached, but here we have LCD, so instead of those binary numbers we can simply write the characters here and these can be displayed on LCD. The rest of it remains the same. The way I already discussed that first of all we are giving the value of rows and the value of column is being searched. Here is our search and then it is given to the database where it detects that what number I have to display on the LCD. Let's move towards our Proteus simulation. Let's run it and try whether our code is working or not. Let me press 3. It is being displayed there for any random number 2 maybe. Yeah, it works fine. This is the SPI part of our serial communication lab number 6. First we have defined all the header files that we need to use. Then we have initialized our LCD. In DDRB we have pulled up MISO, which means master in slave out. Master has been declared as input and slave as output. We are dealing with the slave code because here we have LCD which is output. Here we have an empty while loop so that while the data is being received there is no other task being performed. Once it is over, the interrupt flag will go off and will execute this command which writes whatever we have got the value from the master to the LCD. Let's check the master code. As you can see, the master code remains same as in case of UART. The rows are defined and we need to search for the column. Let's check our Proteus simulation. Two, 6, 7 is being displayed on the LCD. It worked fine. This is the last part of our serial communications lab, the I2C part. Here we have used a few header files and functions. What is in these functions? We are going to discuss it here. Our first function is TWI read slave. In this function there is I2C control register in which we have turned on the interrupt bit and EA bit which controls generation of acknowledge bit and enable bit. Then here with an empty loop we are waiting for interrupt flag to go down and then waiting for the acknowledgement from EA bit. Once the data is received on LCD, we show data received. TWA match read slave. Here in control register we have turned on EA bit, that is acknowledgement, enable and interrupt bit, and waiting for interrupt bit to end. Moving towards our master function, master code. Here even we have used the same functions. In start the specific thing is that we have enabled the STA, which is start bit, and then we are waiting for the condition and then for acknowledgement. The same is happening in repeated start function. In the write address we will turn on the interrupt and enable bit. Here we are waiting for both the acknowledgement and data transfer. In write bit the same thing, and then in the stop we have used the TWSTO, which is for stop function. Moving towards our Proteus simulation, the data is being transferred correctly. We are at our lab 7, in which we have an LCD for output and two switches representing interrupts. In the code, first of all we have included all the header files that we need to use. Then we have declared port B and port C as output for LCD, and port D, which has external interrupts, as input. Then we have pulled on PD0 and PD1 interrupt pins. In external interrupt control register A, we have pulled on interrupt sense control pins. The 00 pin represents interrupt 0 and ISC10 represents interrupt 1. In external interrupt mask we have enabled interrupt 0 and interrupt 1. Then by default we have printed Faisal on our LCD. He is my groupmate. And in these functions, if the first switch is on, then interrupt 0 is called and LCD displays interrupt 0. And if the second switch is on, then interrupt 1 is called and interrupt 1 is displayed on the LCD. This is our lab 8, in which we have to take value from temperature sensor and display it on LCD using Atmel Studio C++ code. First of all we have included all the header files, then we have initialized the LCD and declared port F as input for analog to digital converter. Analog to digital multiplexer, we have turned on REFSO pin. Now what does that mean? Let's have a look at this table. If REFS0 pin is on and the other one is off, this means that we have external capacitor thing. Next we have analog to digital control register. In analog to digital control and status register, we have 8 pins here. We have turned on analog to digital enable, analog to digital interrupt enable, and these 3 pins. These 3 pins are ADPS2 to ADPS0 and they represent deviation factor. We have turned all of them to 1, which means that we have enabled 1 to 8 ADC prescaler. Next we have displayed temperature on the LCD, then this is just a check. Then we're making this thing as an interrupt flag. So until the interrupt flag is 1, we'll wait for the complete conversion. When the conversion takes place, then we will clear the interrupt flag. Then this is a specific value for conversion of voltage to the temperature value. Then we got the value in integer, but LCD displays only characters, so ITOA converts integers to characters. And then in the next line we are displaying the value of LCD. 22 टेम्परेचर है और ये हमारा हो गया कोड हो गया। This is our lab 9, the last for Arduino. We are declaring all the header files as usual. Then PB6 port for output, we need to plug LED there. Then we are doing some settings. Now what settings we are doing here, let's understand them. This is TCCR0A register. If we have a look at it, we are using the COM01 and COM00 pins in 1-0 configuration, which is clear on compare match, and WGM00 and WGM01 pins in 0-1 mode, that is CTC, clear timer on compare match mode. The next setting that we are doing here is that we are making CS00 on. If CS00 is on and the rest of them are off, this means that there is no prescaler. Next we have TIMSK0, in which we are turning on we are enabling the interrupt, and then in the second timer counter control register we are setting it in prescaler mode. Now these are the for loops for increasing brightness from 0 to 55. This is the function, and for decreasing brightness this is the function, and this all is in while loop, so it will slowly fade away its brightness and then increase, and this process will keep on going. But there is a bit of difference in what was happening in our first lab, that was simple blinking, and this blinking is like fading away slowly and then slowly glowing up.
बिट है ना वो यूज़ होगी, ये 4 बिट से इनपुट आ रही है। अगर मैंने इसको चेंज कर दिया तो अभी थर्ड बिट जो है वो यूज़ होगी। थर्ड वाली कौन सी है, 1 2 3 है, ठीक है। अगर मैंने इसको करके ये कर दिया तो ये वाली यूज़ होगी, सॉरी कौन सी यूज़ होगी, यार ये की होगी, ये वाली होगी, ठीक है। और अगर ये मैंने दोनों को नीचे कर दिया तो फिर ये वाली पिन यूज़ होगी।
These two last videos were from the FPGA part of microcontrollers and embedded system labs. We did the coding work on Quartus and Model Sim Altera. So that's all. Thank you for staying so long with me. Allah Hafiz.